Good morning, everyone. We are the group Purple, and our topic for today is all about sampling technique. So first, what is sampling technique? It is the name or other identification of the specific process by which the entities of the sample have been selected. There are two types of sampling, probability sampling and non-probability sampling. Probability sampling, it is a sampling technique in which the subjects of the population get an equal opportunity to be selected as a representative sample. There are four types of probability sampling. Simple random sampling, it includes assigning numbers to all subjects and then using a random number generator to choose random numbers. Second is stratified random sampling. It involves splitting subjects into mutually exclusive groups and use simple random sampling to choose members from the groups. The third one is systematic sampling. It means that you are going to choose every ninth participant from the complete list. And the last one is the cluster random sampling. It is another way to randomly select participants from a list if the population is too large for simple random sampling.
This is the given problem. Surya wants to know from the population of 50 students shown below, select 10 students on the basis of their teams. How does Surya get the list of names of students who are representing for Team Japan if he uses simple random sampling, systematic random sampling, and stratified random sampling?
So these are the steps for simple random sampling. Number one, write the names of each state in a paper or number each student from 1 to 50 if raw data and arrange alphabetically. Number two, pick 10 pieces of paper that contains either names of students or its assigned number. Number three, list down the numbers and the corresponding name of students.
The names of 50 students arranged alphabetically. These are the picked 10 students that contains either names and its assigned number. Number 4, Bertolo. Number 39, Viernes. Number 21, Nalugon. Number 17, Loro. Number 25, Rabela. Number 11, Doria. Number 31, Season. Number 9, Costosa. Number 5, Bradesina. And number 8, Celestial. These are the 10 students and their corresponding assigned number.
Are the steps for systematic random sampling. Number 1. Number each students from 1 to 50, if raw data and arrange alphabetically. Number 2. Solve for k. Number 3. Select a number from the whole numbers between 0 and k plus 1 by simple random technique. The chosen value is called the random start. And number 4. Select and arrange the data.
These are the name of 50 students arranged alphabetically using systematic random sampling. To solve for the k, where k is equal to big N over small n, where k is equal to sample interval and big N is equal to population of students and small n is equal to sample size, where k is equal to 50 over 10 and k is equal to 5 or every fifth, skipping from the arranged data. For the step 3, select a number from the whole numbers between 0 and k plus 1 by simple random technique. The chosen value is called as the random start. Where k plus 1 is equal to 5 plus 1 is equal to 6. The numbers that are between 0 and 6 are 0 to 6. Using simple random technique, 0, 1, 2, 3, 4, 5, 6, and 3 is the random start.
To select and arrange the data, where k is equals to 5 is the sample interval and 3 is the random start, starting with Bersabe on number 3. By adding 5, we have Celestial on number 8. By adding 5 again, we have Espinosilia on number 13. And adding up 5 again, we have Maglantay on number 18, so on and so forth. These are the 10 students picked using systematic random sampling, starting with Bersabe on his assigned number 3. Second, we have Celestial on his assigned number 8. Spinosilia, number 13, Maglantay, number 18, Ong, 23, Sagiing, 28, Tagle, 33, Velasco, 38, Walker 43, Zaragoza 48.
These are the steps
These are
of
four
using
groups, and
stratified
since a
random
total of
sampling.
8 students is
Number
needed for the
1.
sample,
Divide the
2 students
population
must be
into
selected
subgroups
from each
consisting of
subgroup.
males and females. Number 2.
La
Divide
la
each subgroup further into
la
two groups of freshmen and sophomores. Number 3. Determine how many students need to be selected from each subgroup to have a proportional representation of each subgroup in the sample. There are four groups, and since a total of 8 students is needed for the sample, 2 students must be selected from each subgroups.
We need
We
to
need to
divide
divide
the
the
50
50
students
students
into
into
two
two
subgroups
subgroups
consisting
consisting
of
of
males
males
and
and
females.
females.
Step 2. We need to divide each subgroup further into two groups of male and female students. In Group 1, males, Abundo, Bersabe, Cao, Castillo, Celestial, Sendenya, Chenilla, Costosa, Escaño, Gallardo, Dalinde, and Loro. In Group 2, females, Aguas, Bertolo, Rodesina, Juan, Burgos, Quason, Doria, Espinosilla, Linihan, Manalon, Piloton, and Saging. In Group 3, males, Maglantay, Mones, Nalugon, Napatutan, Ong, Ravela, Sabar, Sabenesyo, Salyave, Samson, Sison, Tabon-Tabon, and Tagulaw.
Number 3. Determine how many students need to be selected from each subgroup to have a proportional representation of each subgroup in the sample. There are 4 groups, and since a total of 8 students is needed for the sample, 2 students must be selected from each subgroup. Group number. Number of elements in the subgroup or population size is equals to small letter n. Number of elements in the subgroup is equals to 5. Student population is equals to 50 and a small letter n is equals to 10. Group 1 is equals to 12 over 50 times 10. Group 1 is equals to 2.4. Group 2 is equals to 12 over 50 times 10. Group 2 is equals to 2.4. Group 3 is equals to 13 over 50 times 10 is equals to 2.6. Group 4 is equals to 13 over 50 times 10. Group 4 is equal to 2.6. To wrap it up, 2.4 of group 1 and 2.4 of group 2 plus 2.6 of group 3 and 2.6 of group 4, we have 10. We have 10 students who is represented for Team Japan.
So these are the two students that are selected from each group using random numbers and or draw lots. For group 1, we have Shanilia and Escanio. And for group 2, we have Burgos and Doria. For group 3, we have Mones, Sabenesio, and Tabon-Tabon. For group 4, we have Valdez, Viernes, and Yupo. So these are the 10 students that will represent for Team Japan.